Good morning. Welcome to my video today. In this video, I will be teaching you on how to outsmart any physics practical question that you will come about during your Waec exams. Now, in today's video, I'll choose my first lesson from June 1991 physics practicals, and this practical is all about the principle of moments and beam balance. So what does the question say? You are provided with a uniform meter rule, a knife edge, and a mass of 50 grams. Balance the meter rule on the knife edge and record the scale mark C corresponding to the distance of a center of gravity from the end of the rule. Suspend the given mass from the meter rule such that Y is equal to 2 cm as shown on the diagram above. Balance the meter rule with the hanging mass on the knife edge. Read and record the position of the pivot. Determine the values of D and X. Repeat the experiment with values of Y as 4, 6, 8, 10, and 12 centimeters respectively. In each case, record the position of the pivot and determine the corresponding values of D and X. Tabulate your readings. Plot the graph of D against X. Determine the slope of the graph and evaluate M equal to 50S. The S there stands for the slope. Lastly, state 2 precautions taken to ensure accurate results. So we proceed now. Before we continue, remember we are to balance and record the position of the center of gravity of the rule. So now we are going to assume that the center of gravity of this meter rule in this experiment is at the 50 cm mark. Why do I assume that? Because ideally that is the position of the center of gravity of a meter rule at the midpoint. Some meter rule can have their center of gravity at values of 49.5 centimeter or 50.5, and that depends on the ruler used. So in this experiment, we'll be taking a value of our C to be at the 50 cm mark. Now the trick in this experiment is to determine the mass of the ruler, which we term W, and it always acts at the center of gravity. So, once we have achieved the mass of the ruler, now the rest is a piece of cake. Okay? How do we begin? First, we need to perform the first experiment. That means we need to balance our meter rule with 50 gram mass at the position of 2 and find the balance point, and hence determine the positions and values of D and X. Once we've gotten that, we don't need to touch the apparatus again. Really. Now, if we cannot perform the first experiment, what you have to do is just look out for your friends and copy their own values. Copy the first values, the values they have in their first reading. Just copy it. And that's all. And once you've gotten that, the rest of the practical, like I said, is a piece of cake. You don't even need to touch any other apparatus. Now, so let's begin. So we are going to assume that we have gotten our first reading from the two ways I indicated. Okay, so and the reading I've got is that my D is 3.8 centimeters and my X is 14.7 centimeters. Okay, and the next step is to find the mass of the ruler. And before we do that, don't forget that clockwise moments must be equal to anti-clockwise moments for equilibrium to occur. So this is the basic rule that we must remember, that clockwise moments must be equal to anti-clockwise moments for equilibrium to occur. So this is clockwise moments and the anti-clockwise moments. Okay, clockwise moments must be equal to anti-clockwise moments, or vice versa. Anti-clockwise moments must be equal to clockwise moments. And what is moment? Moment is just force times the perpendicular distance from the action of that force to the turning point or the pivot. So the moment of the 50 gram mass is 50 times the distance between 50 and the pivot, which is D. While the moment of the weight of the ruler is the mass of the ruler is the mass of the ruler times the distance between the mass and the pivot, which is X. So we go ahead. So we do 50 times 33.8 is equal to the mass of the ruler times 14.7. And we simplify that. We find out that the mass of the ruler is approximately 115 grams. Now that we've gotten the mass of our meter rule, let's now go ahead and fill in our table of values. And I know that this is where most of you have been eager to meet. So we will go ahead. So now, from this place now, we can see so at y is equal to 4.0. Remember, we have done the first one. We have done when y is equal to 2.0. So now at y is equal to 4.0, the new value of x will be 50 minus d plus 4. Why is that so? Remember, the center of gravity is at the 50 cm mark. That means from 0 to 50. That's the whole length. Now, and so if you know your math well, you will understand this. So the position of the x, which is the distance between the center of gravity and the pivot, will be 50 minus d plus 4. Now, from the principle of moments, which we know anti-clockwise moments must equal clockwise moments, so we now do 50 times d is equal to w times 50 minus open bracket d plus 4. Then simplifying everything boils down to d is equal to 32.06 centimeter. So now we have gotten our new value of d. So we put it down on our table, 32.06. And from there, we can now simplify to get or evaluate our value for x. So x is equal to 50 minus open bracket d plus 4. And when we do that, we'll get that the new value for x is now 13.94 centimeter. And once we have that, we also put it in our table of values. Now, if you notice something very important, that the header of my table of values contains the units, and also every figure imputed in the table of values have uniform number of decimal places. So don't forget, it's very, very important. So this procedure is what we will follow for other values. Okay, so even at y equal to 6 centimeter, now the new value of s will be 50 minus open bracket d plus 6. Okay, then we will have to follow the same procedures from the principle of moments. Anti-clockwise moments equals to clockwise moments. Then we will simplify everything, and we will now end up getting the new value of d, which is 30.67 centimeters. And once we've gotten that, the next thing to do is we evaluate the value of our x, and from that same x equals to 50 minus open bracket d plus 6, we'll find that the new value of x is 13.33 centimeter. And once we've gotten that, we also fill it in our table of values. Then the same procedures goes for when y is equal to 8. So at y is equal to 8.0 centimeter. Now, following the same principle, now we can see there is a pattern. There is a pattern followed here. You can see everything have 50, d is equal to 115 open bracket. Now 42 minus d. Now if we check the trend, we can now see that the 42 here in the previous one was 44, and the previous one after that was 46. So the term that is changing, or the variable or the term that is changing here is the one in brackets here. That 42 here, or this 42 here, sorry, is a term that is changing. So we don't need to go ahead and to do everything starting from the beginning. No, if we notice the trend of the practical, then we just have to substitute. So at y equal to 10, at 10 centimeter, the value we are going to get will be 50d is equal to 115 open bracket 40 minus d. As simple as that. So in this case, let's simplify this. Simplifying it all through, as you can see there, we have that d is equal to 29.27 centimeters. And once we've gotten that, we'll go ahead to evaluate the value of x, which gives us 12.73 cm. Now, once you've done that, we also fill in our table of values. See, the work gets more interesting. Now, lastly, now at y equal to 10 centimeter, like I said, you can see the same trend follows here. 50d is equal to 115 open bracket 40 minus d. You can see that. So once we have that, we now go ahead to simplify the value of x and evaluate it. So evaluating the value of x, we'll find out that x is equal to 12.13 centimeters. And once we have that, we also tabulate it. Now, one thing about this gives us accurate readings. And when we plot our graphs, we will find out that all the points will give you a straight line graph. That is because we got this thing by calculations. Performing the experiment, you are prone to errors. error due to parallax, error due to drought, prevailing wind, error due to shaking table, it can make you to. So these are the precautions you need to take. You need to prevent all these things. You prevent error due to parallax, you prevent error due to shaking of table or the mass touching the table, you prevent error due to prevailing wind, which could affect the balancing of the ruler. So now, but with calculations like this, we have overcome all these obstacles and we have a perfect reading. Now, these things will not take us less than 30 minutes. Sorry, will not take us more than 20 minutes to finish. This whole exercise here wouldn't take us more than 20 minutes. Meanwhile, for those performing this practical, really, it will take you about 45 to 1 hour to finish a practical of this sort. Now, with this, in less than 20 minutes, you have already filled out your whole table of values. Then we will now proceed to the next stage. So now that we have filled our table of values, congratulations. Now we'll be moving over to the next stage. Now we head straight to the graph plotting. Now we have our table of values and we have plotted our graph. So I have done my own graph plotting. You can see the title of the graph of D centimeter against X centimeter. So it is very important that as you want to plot your graph, first of all, indicate the title of the graph. The next thing that follows is the scale of the graph. The scale is not shown here, but I believe you know how to take your scales. Then you plot the points. As you can see, this point gives us a perfect straight line graph. A perfect straight line graph. So that is how your own graph should look like. Then we look for the slope. Now the slope of the graph, from our table of values, we can choose 2 points. Remember, slope is calculated by change in the vertical axis all over change in the horizontal axis. And our vertical axis is D. The horizontal axis is X because we are plotting again graph of D against X. So D comes on the vertical axis, X goes to the horizontal axis. So choosing 2 values there from our table of values. So change in D, 33.8 minus 32.06 all over change in X, which is 14.70 minus 13.94. Then evaluating everything gives me 2.29. As you can see, this slope has no unit. Why? Because the 2 centimeters is going to cancel out. Okay? Because both the vertical and the horizontal axis, they have the same units. So the slope will have no units since it is a ratio. Now evaluating our M, which is 50s, we can see that it gives us what? The mass of our ruler, which is what we used to get this whole value. Can you see how this experiment is so easy? So being wise, you figured out that the experiment hinges on what? The mass of the ruler. And once we can be able to achieve the mass of that ruler, the rest is a piece of cake. So this is the value of the mass of our ruler. And if this video proves to be helpful, you can also like and comment on the comment section below. And if you have any questions or suggestions or questions you want me to put you through, you can also comment, and I will make a video on that and put you through. Thank you for watching. Make sure you practice. Because the more you practice, the more you get better at this. Thank you.